औज़ुबिल्लाहिमिनश्शैतानिर्रजीम बिस्मिल्लाहिर्रहमानिर्रहीम. So dear students, आज हम ऑर्गेनिक केमिस्ट्री रिएजेंट सीरीज में बात करेंगे अबाउट अनदर ऑक्सीडाइजिंग एजेंट दैट इज द हाइड्रोजन पेरोक्साइड. ठीक है, तो स्टार्ट हाइड्रोजन पेरोक्साइड, that's your H2O2, and we write it as hydrogen peroxide, that is O, then another O, and then H. So this OO is called as peroxide linkage. Now इसकी जो oxidation property है या इसका जो tendency है to oxidize the substrates, that I will divide into 4 classes. ठीक है, for our convenience. So number 1, so it acts as oxidizing agent as in presence of iron 2. So I will write it H2O2 in presence of iron di-positive. Number 1. Now this is very, very important. Oxidation tendency of the peroxide in presence of the iron 2. Number 2 as a neutral form, means as it. हाइड्रोजन पेरोक्साइड जो है, I will use this as oxidizing agent, लेकिन वो जो मीडियम का pH होगा that is around 7, neutral pH. ठीक है. Now third one, in alkaline medium, hydrogen peroxide as oxidizing agent in the alkaline medium, that is when the pH is greater than 7. That's your third category. And fourth one, that is hydrogen peroxide as oxidizing agent in the acidic medium. I will show it like this. So we can divide this into 4 classes. Now in today's class, I will be talking about use of hydrogen peroxide as oxidizing agent in presence of iron 2, that is ferrous iron, and in the neutral medium. So I will be discussing these two, and the next class I will be discussing the next two. Okay, so we'll start. First of all, the peroxide as oxidizing agent in presence of iron 2, this is called as, very important, Fenton reagent. Fenton reagent. Fenton reagent. So before we'll start, it is its actual information, that is the organic transformation related problems. I want to discuss that when we have iron 2 in presence of peroxide, what happens? Iron 2, when it is in the form of peroxide, so then there are some chemical species are generated. So this is our peroxide. So when it is in presence of iron 2, what happens? So it reacts with the iron 2, it results in the formation of, now this undergoes the homolytic cleavage, so that you have basically, so in this you basically get the 2 radicals, OH and OH. So these are 2 radicals, number 1. And then iron 2, it donates 1 electron to 1 radical. So it forms iron 3, that's iron plus 3. So iron plus 2 is getting oxidized to ferrous to ferric state. And this one will get converted to, after getting 1 electron, to hydroxide ion. So in it, we have basically, when we say Fenton's reagent, then we have 3 species in the medium, that is hydroxide radical, this one, we have hydroxide ion, and we have the ferric ion present in the medium. ये बहुत important है. ठीक है. Now let's talk about its application, जो important है. As far as the Fenton's reagent is concerned, its application is concerned, application of Fenton's reagent is with 2 important application. Number 1, since it acts as oxidizing agent, it converts benzene if you have benzene, it converts benzene to phenol. So basically what is happening here, we have that hydrogen here, we know we have 6 hydrogens on this C6H6. So what we are doing, it's actually getting converted to OH here. That means we are inserting oxygen here. So that is your oxidation. That is due to this peroxide. This is called as first property as an oxidizing agent of the Fenton reagent. It converts benzene into phenol. Now if you talk about the mechanism a bit quickly, how this happens. So basically if you see the mechanism of this, as per the mechanism is concerned, you have your phenol, sorry, your benzene. So in presence of peroxide, it gives 1 electron to this. Okay, so 1 electron moves here and 1 electron here. Take a single electron based mechanism. So then what you get out of it, you get this type of intermediate. So you get a negative charge here in the form of, you get an OH. So 1 electron from this radical and 1 electron from this pi bond. Then you have 1 electron here. Okay. So then that iron which is present in the medium is Fe plus 3. So what is that? This electron, it donates to that iron. So what you get finally? You get an interesting species where in the benzene ring at 1 carbon you have complete plus charge. And now this species has lost, even though there is some conjugation, some resonance, but partial resonance in comparison to the product. So this will get released to gain that stability back. That you will get conjugation extra across the 6 carbons now, and the product is your phenol. That's it. So that's your mechanism of your formation of phenol. Now another important application of this Fenton reagent is, first is it converts your benzene into phenol. Number 2, it converts alpha hydroxy, you know these are important things, alpha hydroxy carboxylic acids. If these are substrates where we have the hydroxyl group present at the alpha position, it will convert that alpha hydroxy carboxylic acid into alpha ketone. That is C double bond O, alpha ketone based carboxylic acid. Let's take the example. Let's have example. This is a compound. This is hydroxyl group. So this is your alpha carbon because this is functional group. Next to that is alpha hydroxy carboxylic acid. So if you have on the arrow written that it is Fe plus 2 and peroxide, so that means it's a Fenton reagent. And what we have to do, we have to convert this alpha hydroxyl group into the ketone, simple as that. So we write down the product as R C. Hydroxyl will get oxidized to the ketone, which is the next level of oxidation of alcohols, and then we'll get simply COOH. So that is your product. That's alpha keto carboxylic acid. Okay. This is all about the reactions. As per the reactions is concerned, you can take one more example. Let's take one more example of it. Let's have let's see another example. Example number 2. You have a carboxylic acid, and then you have this CH group here, and this type. Then you have here now ये बहुत important reaction. It has been asked many times in the exams. Let's say we have 3 OH groups present. say we have this way also. Okay, so we have finally CH2OH. So we have to remember it will only oxidize the alpha hydroxy. This is our functional group. Next to this is alpha, this is beta, this is gamma carbon, this is delta hydroxyl groups, fine. So it will oxidize this one only, remember this. So the product will be, so you treat this with peroxide and in presence of ferrous ion, so you will get, this is your carboxylic acid group. This COH will get converted to this, and then you have as normal these groups. 2, and then you have CH2OH. This is very important. Remember, it doesn't oxidizes the other hydroxyl parts. It oxidizes selectively. It's a regioselective reaction. It oxidizes the alpha hydroxyl group into a ketonic function. This is very important. Okay? So this is only about the जहाँ पे questions आ सकता है your competitive exams. So this is only where from the questions can be asked. इसके अलावा hydrogen peroxide in the Fenton reagent need not worry about. Now let's talk about the another aspect of it, that is it's acting as an oxidizing agent but in the form of H2O2, that is in the neutral medium. Okay? So let's take some examples of in the neutral medium. Or I will take it to a different one here. In the neutral medium, okay? So in neutral medium, so we have simply peroxide H2O2. Okay? So what it does, I write down the convergence. If we have a simple carboxylic acid, in the neutral medium you treat this with the hydrogen peroxide. What is the product formed? The next reactions, if you have 3-degree amine, for example, this is 3-degree amine. You treat this with the neutral hydrogen peroxide. What is our product formed? One more example, you can take the selenium based compound. Okay? You treat this with the hydrogen peroxide. So what is the product formed? Like if you have oxygen sulfur based compound. On treatment with hydrogen peroxide, what is the product formed? Okay? So let's first discuss these and then we'll take another aspect. Okay, what it does, it in the form of neutral, under the neutral conditions, peroxide gives its oxygen, simple as that, in shortcut, and then it inserts that oxygen in the acid. It forms per acid. Okay, so you can write down R C double bond O. Now this inserts an oxygen here. This is called as per acid. Simple. ठीक है, इसमें ज़्यादा mechanism का इतना ज़्यादा not to worry about. Now in this case, it converts this into N oxide. Very simple. So it gets oxygen and then nitrogen here a plus. It gets N oxide. Selenium forms selenium oxide. That is your selenium oxide. Sulfur as sulfur oxide. And that's the product formed. तो बहुत आसान है, इसमें ज़्यादा इतना कोई complexity नहीं है, very simple. Now जो another application है, that is it converts nitroamines into, we know, जिस तरह कार्बन की next level, first level of oxidations, it goes from CH2 alcohol. So हमने पहले discuss किया था that if you have carbon as CH, you oxidize that, it will go to alcoholic state. Next oxidation level, that is ketone or aldehyde, and next oxidation level, that is your carboxylic acid. And if you further oxidize this, then you will get carbon dioxide, the final oxidation product of carbon dioxide. Same is the case with the amines. If this is amine, you oxidize this, the next level of oxidation is always nitro. Remember this. So amine get nitro. Same is what actually this does, your peroxide. So peroxide converts your amines to nitro compounds. That means it converts your NH2 group to nitro group. Let's take some couple of examples and then we'll finish today's class. Let's say we have a primary amine, CH3, CH2. This is a primary amine, and then we have one more aromatic amine. This is your aniline compound. So you treat them with the peroxide under neutral conditions. So what is the product formed? Same is the case here. You treat with this with the peroxide and then check what is the compound formed. Okay. So it's very simple that it will oxidize this amine group into the next level of oxidation, that is the nitro. Same is the case here. So your product will be CH3, CH2, CH2 and your NO2. So the amine group has got converted into the nitro group, that is the next level of oxidation, likely for the nitro compounds. So this will get converted to nitrobenzene. That's it. So these are only the two important concepts as far as the peroxide is concerned, that when it acts as an oxidizing agent, it oxidizes the organic substrates or inorganic substrates, for example the selenium and sulfur compounds. So it oxidizes them to the next level of oxygen. Now there's one question that how this peroxide basically converts these Se, sulfur and amines to oxides. I think that is not required as far as the competitive exams is concerned, that mechanism. So need not to worry about. We have to remember that it converts tertiary amines into this nitrogen oxides. It's called as nitrogen oxide. And it converts this into selenium oxide. And this is sulfur oxide. So that we can remember. And then it also converts amines into the nitro compounds when we use peroxide as in the neutral form. So now we are left with two topics in the peroxide chemistry as an oxidizing agent, that is it's acting as an oxidizing agent when the conditions are when the conditions are alkaline and when the conditions are acidic. So those two aspects and the organic transformations and the problems जो usually ask हो जाती है in the competitive exams, so they will be discussing the next class. ठीक है? This is all about our today's class in this organic reagent series. So thank you.